All right. Hello, everyone. Welcome to the KubeEdge community meeting. Today is October 28th. It's Europe-friendly time this week. So, so today it looks like we have new members joining the meeting. Would you like to give introduction yourself? And after that, after the agenda, we can go through the 1.5 feature development updates.
Okay. Kevin, this is Senthil. You want me to introduce myself now?
Yeah.
Okay. Do you want me to do the presentation also now or later?
Yeah, I think we can first go through introduction to from all the new members. Then we can start the
Okay.
presentation.
Okay. Sounds good, Kevin. So, hello everybody. So, I am Senthil. I'm currently working in Ericsson. I'm working in Ericsson for Global AI Accelerator here in India. So I work out of the Chennai office in India. And before joining Ericsson, I was working with other companies. So I have worked with Huawei in Bangalore. I have worked with Nokia, and I have also worked with IT service companies like Wipro and Cognizant. So my areas of specialization or my areas of interest is one thing is Kubernetes and another one is edge computing. And I do some open source work during my free time. I write some blogs in medium.com and as well as in LinkedIn. So I am actually very keen on the KubeEdge project because it is related to edge computing. So I am very interested in the KubeEdge project, and I'm very glad to get connected with the community over Slack. So that's my introduction. Thank you.
Thank you. All right. Let me check if anyone else would like to give introduction. Let me ask in Chinese again. Looks we have some member from Chinese. 哎，还有谁想自我介绍的吗？我看今天有一些新同学。No? All right. If not, maybe we can start the presentation. Cynthia, would you like to share your screen?
Yes, Kevin.
All right.
I'm going to share my screen.
Okay, I released the screen, so you can share it now.
Okay. So, are you able to see my screen?
Yes, yes.
Okay, great. So thank you everybody for joining this presentation. So I would like to talk about you about an open source project called as KubeFledged. So this is a project that I started in 2018, and I thought it would be very interesting for the KubeEdge community to understand what this project is all about. And I also feel that Cube-fledged will also be beneficial in KubeEdge project. So that's the reason I requested Kevin to give me this opportunity to present this project. Okay. Again, a little bit of me. So as I said earlier, currently I am with Ericsson. global AI accelerator as a software engineer, and I specialize in distributed systems, edge computing, cloud native software development, and very recently I have also picked up some interest in chaos engineering and of course Kubernetes and Google Cloud Platform. And I am a certified Kubernetes administrator and also a Google Cloud professional cloud architect. And I maintain this open source project called as KubeFledged, and there are a couple of more other contributors as well. So that's about me. So I will not spend more time about me. So I will now go directly to the project. Okay. So to give you all an overview about KubeFledged, it is actually a Kubernetes add-on, which I have implemented using Kubernetes CRD and controller. So once a Kubernetes cluster is running, we just install KubeFledged as an add-on. So that is how it gets installed or deployed. So what is the purpose of KubeFledged, or why do we need KubeFledged? So let's say I have a Kubernetes cluster, right? And this cluster will pull images from a image registry, right? So if we want these images to be made available for immediate use for deploying the pods. So when the pod starts up, Kubelet will pull the image from the image registry. So it will take some time for the images to get downloaded from the image registry onto the worker nodes. So in order to reduce this time, KubeFledged provides a feature for caching the images directly on the worker nodes. So using KubeFledged, we can define what are the images that we want to be cached, and we can also define to which worker nodes these images should be cached, and then KubeFledged will pull those images onto the corresponding worker nodes. So the advantage of this is application pods, when they are created, they can start almost instantaneously because the image will be already available in the node. So if the image pull policy in the pod is set to uh, uh, already present. So if it indicates that there is no need to pull the image when the image is already present, then the pods will start instantaneously. It is an open sourced project under Apache 2.0 license. And now coming on to the use cases. So what are the use cases in which we can use KubeFledged? So I have listed down 3 use cases. So one is real-time applications. So real-time data processing applications or real-time monitoring applications which process time series data. So these kind of applications will require quick startup or even quick scaling. So in those cases, if the images are already available in the worker nodes, it will be useful. And second use case is serverless functions. Whenever the functions are actually packaged as a container images, and the functions need to react to events immediately. So if the functions need to react, or if the function needs to execute immediately, then also we can use KubeFledged. And third is if you are running your applications on the edge, let's say you have designed a cluster which spreads across edge devices. And let's say these edge devices are connected to the image registry in the cloud. And if there is some network connectivity issue in reaching to the image registry, then in those cases also KubeFledge will be useful, because then the images in the local worker nodes will be used instead of trying to pull those images from the image registry. So especially in the edge computing environment, there is a need to tolerate network connectivity issues. So from that point of view, KubeFledge will be useful. And this project actually supports three different container runtimes: Docker, Containerd, and CRIO. So we support all these three different container runtimes, and we also support all these three platforms. In Linux platform, we support the AMD 64 architecture, ARM 32-bit, as well as ARM 64-bit. So all these three platforms are supported. And when it comes to installation methods, again, we support three different installation methods for KubeFledged. So either using YAML manifests. So the repo itself contains YAML manifests, so which can be used to deploy KubeFledged. And the repo also has a Helm chart, and it also has a Helm operator. So whichever method is convenient for the users, they can use the appropriate installation methods. Okay. Now, after the introduction of KubeFledged, here are the list of features that are currently available in KubeFledged. Uh, so the first feature is you can actually cache cache images onto all the nodes in the Kubernetes cluster. So that is one feature. So caching is basically we are pulling the images. We are pre-pulling the images onto the worker nodes. So it is possible to pull images onto all the worker nodes if that is what the requirement is. But if the requirement is to pull those images only to a subset of nodes, so if you want the images to be available only on certain nodes, so that is also possible. So in the image cache manifest, you can specify a node selector. So if you specify a node selector, then KubeFledged will pull those images only to the nodes that are resolved by the node selector. So third feature is automatic caching for new nodes. So when the cluster is growing and if new nodes are actually added, so KubeFledged will automatically detect the addition of this new node, and it will automatically cache the image onto this new node. So there is no need to manually intervene for this new node. Fourth feature is refresh. So if you want to refresh the cache, okay, so refresh the cache in the sense, if you want to actually pull the images again, if you have already, if the images are already available in the worker node, and for some reason you want to re-pull the images, so that can also be configured. So you can actually configure KubeFledged for automatic refresh of the cache. So what happens is you will configure the refresh frequency, let's say 10 minutes or 15 minutes. So once this timer expires, it will automatically pull the images again onto the cache. And you can also manually trigger the refresh by way of annotating the image cache manifest. So if you apply a certain annotation, you can actually trigger the refresh. And fifth feature is both public and private registries are supported. So in case of private registries, you can specify the image pull secret. You have to first create an secret of type Docker, and you put your credentials into that secret, and then you reference that secret within the image cache manifest. And sixth feature is you can also purge the image cache. You can purge in the sense if you want to delete all the images that are available in the cache, you can do so. And you can also, even if you want the entire cache itself to be removed, then you can also do that. So so we have all these 6 features available in KubeEdge. Okay, so thank you so much. So any questions? Any questions? If you want, you can ask.
Anyone have any question?
Hello. Could you show us the CRD files for
Yes,
the example?
yes, I'll show it.
Thank you.
So this is the repository. Okay, so here under the deploy, I have the image cache. Okay, I have it here. So I will probably zoom it. Okay. Okay, so this is the API. So there is a kind called as image cache. So currently it is in V1 Alpha 1 version. And if you look at the spec, right? So if you look at the spec, inside the cache spec, so this is where you actually specify what are the images that you want to pull and onto what nodes that you want to pull. So this cache spec, you can specify multiple list of images. So here I have one list, and then here I have the second list. So in the first list, I have put these 2 images, and here I haven't selected any node selector. So here this list doesn't has any node selector. So these 2 images will be pulled to all the nodes. So whereas in the second list, again here I have put 2 images, but here I have specified a node selector. So what happens is these 2 images will be pulled only to the nodes that have this label. Only the nodes that have this node selector label. So likewise, you can have multiple list of images within this cache spec. And finally, this is where you put your image pull secret for your private repository. So if you have images mentioned from private registries, you can put the image pull secrets one by one here. So this is how it looks like. So once you submit this YAML file using kubectl apply, then automatically KubeFledged will read this and it will automatically trigger pulling those images. That's how it works.
Okay, thank you.
Okay. And if you have any further questions also, please feel free to go through this repo. So I have added a README file with all the necessary information. So you can simply go through this README file. I have given all the steps also.
Thanks. Thanks. I actually have a question. So I'd like to know because we know that kubelet they have the image GC mechanism, right, to save up the disk when it's under pressure. So I would like to know how kubeflash coordinate with this. I mean, what if the cache deleted by kubelet when under disk pressure?
Yeah, correct. That's a very good question. So what happens is if kubelet image GC deletes any image that is present in the cache, so what happens is that's why we have a refresh option. So there is an refresh option. So it will automatically during the next refresh cycle. So here you have to specify the refresh frequency. So then during the next refresh cycle, the image will be updated in the cache. So even if kubelet image GC deletes it due to disk pressure, you can make use of this refresh mechanism to have it again.
Okay, thank you. And another question is more about the edge computing network. So we know that in some cases the node may be located in a very far away on the internet from the central cloud, right? So the connection between the cloud and the edge may be low quality. So I'd like to know if there's any specific technology used here when fetching images or not.
Yeah, that is also a very good question. So currently there is no such mechanism implemented in KubeFledged. For instance, like a retry mechanism or compressing mechanism. So we don't have any such feature implemented in KubeFledged. But if you think a feature like that will be useful, then definitely I can see to implement it. But currently, no. If while pulling the image, if it will automatically do a back off and then try to pull it again, and then once the final timer expires, then it will be reported as an error. So then it will retry during the next refresh cycle. So if the image was not pulled during the first attempt, then it will again retry during the next refresh cycle. But apart from that, we don't have anything special to cater to the network connectivity issues while pulling.
All right, thank you. So the last question is that is it possible to load some image from a? So maybe another option is that we don't download the images from the central registry, right? So is there any capability to load from somewhere like local storage or somewhere else? So maybe the when the users they can prepare the images there and they don't need to go through the things over internet.
Yeah, that is also a very good question. I think, but we can implement those features. But currently, we don't have that feature. So currently, it will try to pull the image only from the image registry. But if we want images from a different source, probably from a disk that is attached to the worker node, then we can look at implementing it.
All right.
Yeah. Yeah.
Okay. Anyone have any other questions?
看哥，喂，听得见吗？我有个问题，就是我不好意思，我英语不太好，麻烦你翻译一下。就是在我的理解，它应该是你抓一些 controllers 生成一堆 job，然后把这些 job 给部署到一些需要去 pull image 的一些节点上面。然后问题是，这类 job 的话，它是通过怎样的形式去 pull 这个 image 呢？是那种只是一些脚本就这样 Docker image pull， 还是说要跟 Docker daemon 这种交互的形式去 pull 这 images？
All right. Let me rephrase the question. So the question was that his understanding is that there's a controller in the cloud creating some jobs to and the jobs scheduled actually some pods scheduled to the nodes to interact with the Docker daemon to pull the image, or is this working in this mechanism or other way?
Yes, it is working in this mechanism. So you can actually refer to this section. So what happens is there is a job that is created for every node and every image. So this job will actually create a pod, and then automatically kubelet will pull the image, and then we just stop it there. We just don't execute any command inside the container. So the container will not start. So we just stop by pulling the images. So that is how it works. We create jobs, and then the kubelet will talk to the container runtime. So we support Docker, Containerd, and CRI-O. So all these three runtimes are supported, and that is how we pull those images. His understanding is correct.
So you mean you're actually asking kubelet to interact with the runtime to download the image, right?
Yes, correct.
Okay. Any other questions?
看个，就是像 containerd 或者 CRI-O， 它是有这个image pull 的这个能力吗？
这个是有的，是有的。
好的，谢谢。
All right. Thanks again. Thank you for the great presentation.
Okay. Thank you so much, Kevin. Thank you so much, everybody, for your time. If you want any new features to be implemented in KubeFledged, please feel free to go and raise an issue here. Then definitely I will take a look and try to implement it. And second thing is, if you feel this will be useful in KubeEdge, then again you can also try to use it in KubeEdge. Okay. So thank you, everybody. Thank you for your time. Thanks, Kevin. Bye.
Thank you. All right. So let's move on to the next item. The next one is gateway proposal by Fan Fees. Hello.
喂，凯文哥你好。
可以听到。
就是说我其实就是把之前那个1G Gateway 那个 PR 搬上来了，然后自己加了点，对，就是这个情况。
你还要再介绍一下吗？
就是说 就是有几个问题嘛，就是想问一下，就是这个EG Gateway 它之前那个 PR 它其实是实现了一个 ingress 的一个边端的一个 ingress 的一个功能，然后但是它又用那个 Istio 的那个 Gateway 跟那个 Virtual Service 嘛，这两个的话就是 Istio 的那两个资源对象。然后这样的我就在想，就是 EG Gateway 它是否要实现就像 Istio 的那一套简化的功能呢？还是说这个 EG Gateway 它只是一个 Istio 的一个 process 这样一个形式部署在上面，这样一个情况？
这个实际上so let me rephrase the in English first. So the discussion is about the gateway proposal. So we actually have some discussion already in previous months. So the background was that currently KubeEdge didn't provide support for ingress or node pod. So that makes the automation that makes there's no automation for the services exposing for the external request when the pod is on the edge. So actually the background is trying to resolve that. So initially the contributors think that we can directly implement ingress, but the problem is that ingress is actually a cluster-wide API, so it cannot work very well when the nodes are located in different edge network. So then they move to the idea using the Istio Gateway API. Istio Gateway API is a little bit different to the Ingress API. It's actually not cluster-wide. So the initial proposal here previously was to actually just implement the Istio Gateway in KubeEdge. So that's the background. 就是说，它其实原来还是要去实现这个 Istio 的这个 Gateway 的 API， 但是呢，它其实原来想说的是，这些实现是放在那个 Edge Mesh 里面做。
所以说现在是打算把它分开是吧？就是说 EG Mesh 做的就是就靠里面的，然后 EG Gateway 它就做外部的一部分，就是跟那个 Event Bus 进行那个交互是吧？
这里其实有几个遗留的问题，就是呢，因为有一些场景，其实简单的场景来说，节点会在一个网络里，边缘节点也会在一个网络里，所以其实 Ingress 还是要支持的。然后另外的就是说，另外的场景呢，其实就现在这个 Edge Gateway 到底是不是 Edge Mesh 实现？后来又有一些讨论，还不是很确定。最主要是因为，如果比如说我们去支持一些 List Watch 能力，那么它可以直接去集成 Istio， 就或者说我们找到一个更好的方法，能够把 Istio 整体的集成进来，这样的话就避免自己去开发嘛。
对对对，是这样的。
对。然后另外就是第三点就其实还是我们之前讨论过的，就是说Edge Mesh 它在不同的 use case 下，其实它的覆盖的能力层次是，或者说它用到的能力层次是不一样的。Edge Mesh 现在按照我们前面已经讨论过的一些点，它其实包含到了接近3层或者4层，就是3个层次或者说4个层次。最底下的实际上是那个这个容器网络嘛，因为在没有容器网络的时候，其实 Edge Gateway 可以提供一个基于主机网络的一个容器间的通信方式。然后第二层实际上 Edge Gateway Edge Mesh 里面是 Edge Mesh 里面目前其实它有一个类似于 Class 的 API 的Class 的 IP 的这个LB 的机制，但它其实也是 底下是可以 work on 这个就是它基于 host 的这个容器网络对应的这层，然后再往上实际上是这个节点级的 DNS 解析，然后再往上是未来其实 Edge Mesh 还想去构建这个 Service Mesh 的能力嘛，在边缘，那所以它这个有4个 level，那其实在不同的这个网络环境下，它比如说容器网络，其实我们可以用其他社区的这个第三方的容器网络，对，然后还有就是 Cluster IP 这层，其实也可以用，在这个网络如果都是通的情况下，其实可以用这个 Kube Proxy。对，然后所以其实这个实际上是要看用户的不同的网络环境的。
哦，这样的是吧？哦，那这个一级 gateway 的定位是不是要修改一下？
对，所以这个地方就是说，要不然我们是作为一个单独的 API，只是说参考 Istio Gateway 的这个 API 做个引入，但实际上就完全是自己的实现。
哦，这个意思是吧？好的。
对，然后实现上其实这个实现上我觉得可以，因为原来只是初始的时候是做的是直接做在 Edge Mesh 里面，现在其实这个地方可以重新看，因为它也有可能在不同的环境下，就是使用到 Edge Mesh 的能力不一样嘛，所以这个就是代码放在哪里，我觉得应该都 OK。
好的，明白了。
All right, so let me just rephrase in English. So I just covered the background before, and the proposal last time is actually covering about how to introduce edge gateway capability. So actually this one depends on different network environment. So we know that Ingress is a cluster-wide API. So in some cases, the user may still have the network that all the nodes and the masters are able to communicate with each other. So in that case, people may still want to use Ingress because that's very vanilla functionality and already have some third-party adoption on that. And the second case is that Edge Gateway is trying to provide actually make it possible for the external request to reach out some of the pods located in a subnet, a specific subnet. So in the network environment that agent locates in different subnet, it's very useful. And the third thing is that actually for the edge mesh under discussion is actually covering 4 layers. So the underlying is the actually the container networking. Currently, if there's no any CNI plugin installed, Edge Gateway can provide a pod-to-pod communication through host network. So basically the network of nodes. Secondly, Edge Mesh currently have a equivalent capability of equivalent capability of internal load balancing, just the same to cluster IP, but it's able to work on the host network if there's no CNI plugin installed. The third layer is node level DNS resolution. And the fourth layer is advanced traffic routing, traffic management, just like service mesh. So the discussion is that edge gateway should be edge mesh should be able to provide different capability sets due to different networking environment. So with this background, edge gateway, this capability, we think it should be decoupled to the other functionalities. So maybe we can just introduce as a new CRD or new API provided by KubeEdge. And in the cases that the underlying network is all reachable between nodes, maybe we can also find a way to integrate with Istio, so that then the user can get full power of Istio. All right, that's all about this topic. Any questions, or we can move on to the developer updates?
看过。喂，就是我一直想问，就是对于 gateway 它什么时候才会用到呢？因为假如我们支持 list-watch 的话，我边缘直接布一个 ingress 就好 ，ingress controller。
list-watch 还有一个限制，就是 list-watch 解决的是你的边缘的第三方的应用跟控制面的通信，对吧？但是 ingress 它一旦要引入，如果在跨 subnet 的情况下，那么其实你得支持跨 subnet 的通信才行，不然它接入点就是访问的入口跟 endpoint 如果不在一个 subnet， 它还是没法通。
那这个 edge gateway 它也要支持跨10万的这个流量代理。
edge gateway 实际上它的就是初始的含义是说，它的一个对外的一个类似于 ingress 的对外暴露的一个入口，可以只导给部分的后端，而不是导到全集群的。但这里有一个问题，就是因为它的语义设计 API 的这个设计上，你可能没有办法做这个很直接的限制，那就是有可能，比如说用户配错啊这种情况，你到底是不可用还是要帮他走通，就是这是我们要取舍的嘛。
但是如果是在边缘网络的话，那其实这个流量也是代理不到云端去嘛。
对，它可能是在不同的边缘之间有这种跨边缘的这种访问。
在我的理解里面呢，这edge gateway就是它后端的那些 endpoint 不应该都是在一个局域网内的。就开文哥的意思是，可能这些 endpoint 也可能是就是分布在不同的子网底下嘛。
因为实际上按照 Kubernetes 的这个设计，就是你的一个部署 scheduling 跟你的 service 或者就是对应的像 ingress 这种，它是两个正交的平面。然后如果我们要引入这个限制，就意味着你要去限制用户的那个他在部署的时候做这些限制，对吧？那其实还是说用户得要求用户配置正确，如果用户配置不正确，那你就会这个功能就端到端是走不通的，这就会成为一个问题。
其实我们现在落地的场景化的话来说，我们的一个 service 或者说一个 deployment，一般来说创建一个 deployment 会自动创建一个 service 对象，然后这个同属一个 service 的 pod 都是在一个那个子网底下。如果发现或者说在一个数据中心内的，因为一个数据中心内的网络它们是不同的嘛。现在看的话，像跨数据中心的那种访问的话，比较麻烦，所以并且我们也不好管理。就是如果一个 deployment，它的这个 pod 是也分布在不同的数据中心上面。对的。
是的，所以就是说，这个就 偏向于实施的时候，比如说，其实你应该给节点都打上 label，就是哪些节点分布在相同的数据中心，然后在 pod 部署的时候，其实它应该也要打上，对吧？就是它分布到哪个数据中心。那在这样的情况下，其实你做这个 Edge Gateway，然后你也用上同样的 selector，那么它是可以正常使用的。但是其他的情况，如果用户不加这些限制的话，很可能就不能用。所以这个地方，我暂时也没有太好的一个方法，就是说，就是到底我们要不要就直接把它限死？
那这样子的话，那这样子的话，那必须得Edge Mesh它支持那种跨子网的通信，这个这在做了吗？
之前是之前丁英说他要设计，但是我看好像一直没有进度。
好的，谢谢凯文哥。
Okay, so the discussion is still about the Edge gateway. So just want to identify the different case between using service mesh like Istio. So the question is actually that if we support list watch from Edge for the third-party applications, do we still need the Edge gateway? So actually, the list watch on Edge is providing support for the applications talk to Kubernetes API, but the data plan, the pod-to-pod communication across different subnets still need additional functionality support. It's not yet covered by list watch on Edge. So in that case, we can, if the cross-subnet communication not yet supported, we cannot integrate with service mesh because the end-to-end communication may still be broken. Right. So in that case, we may still need to consider whether we should use Edge Gateway. Another problem is that we know that Edge Gateway, the idea is to limit the backend, the endpoint inside the same subnet that the access point is reachable. But the difficult is that we know that in Kubernetes, the design is that the pod are defined by deployment and scheduled by scheduler. And the service is actually just a kind of internal load balancing relation binding to the endpoints. So they are, we cannot restrict the pod location from a service API. So that's the difficulty. So in cases users didn't enforce the restriction to make sure the pod location defined in the deployment are same idea with the service or ingress definition or gateway definition, then the end-to-end functionality will be broken. So here we need to balance the trade-off of designing this end-to-end behavior. Okay. So let's move on to the 1.5 feature updates. So according to the calendar, I think we have only, let me check. So I think we have only 2 weeks until we make this release, right? Just let me check. All right, so let's go through the feature list. EXEC to the edge, that one is already implemented. The KEadmin get data, any updates on this or still waiting for review?这个有什么新的进展吗？
喂，这个我已经审核过一遍了，然后他现在正在有一些函数写的不好，我让他再重构了。
OK，这个要抓紧一点，因为那个我们只有2周了，2周就要发版本了。
好的。
Okay, edge node cross subnet communication still under design. Improving a release process. I think this one is actually pending, waiting for review. And also the Debian package support. This is also under review. Okay, and support list watch. Any updates on this? Last time it was said we need some review comments as input.
喂，Cal 就这边这个刘志磊他的版本目前也正在实现当中，但是飞哥那边可能有就是不一样的想法，互相借鉴吧，这估计还是得到下一个版本了。
OK。Okay, KEadmin reset. This one is implemented. So website upgrade. This one actually we almost finished the upgrade, but the styling looks not improved enough. We may still need some styling improvement. So maybe we will just have it on the development branch and wait for more improvement, and then we can replace the main set. So here we already support different versions. We just need to update the configuration. And the home page, I think we may need to add more section like introduction to the overall architecture. And the recent update is that we have a blog list page design, but the detail styling still need improvement. And the other events. No. Okay, so the community, we have the join community page and also the partner page and the case study page, but it looks very still in the early stage for the styling thing. So functionality wise, it's enough. So we just need more improvement on this. Okay. Let me add more details. Okay, data pipeline, this one is pending. Model-bus mapper Go implementation. So this one we have pull request this week.
对，这个代码前几天发出来了。
对，我们这次要不要直接独立仓库，还是 或者最好是不是独立一个文件夹？因为我看这现在有2个文件夹，对吧？一个 common 和一个，
对，
看一下能不能直接点过去。对，因为这样可能我担心后面是不是不好分。现在就是 Modbus Mapper 跟 Modbus 这2个文件夹看起来比较不好区分。
下面那个是原来的我没敢删。
对，所以就是要不然我们是文件夹上加一层还是怎么样？这个蓝牙的是 Golang 的对吧？
对，Golang 的。
所以要不然我们把这3个合到一个，比如说叫 Modbus，叫 Mapper 杠 Go 之类的目录里面去，或者其他的，暂时也没什么好的 idea。你的这个 comment 里面放的是什么？
就是一些就是其他的，如果要写 map 的话，可以调的那些共用的 API。
OK。那我觉得，要不然我们就是我想想，或者你现在先把这2个先合到一个目录里，我们就直接后面可以直接拆出去，拆一个独立库，然后其他的都往里面放。觉得，或者我想想，现在好像其他的我没什么好的 idea，或者就是还有个最那个的办法，就是加个 readme 这里写一下这几个目录的关系。
可以。加个 readme 讲一下。你说那个拆新的那个话，现在拆好拆吗？马上就要发版本了。
那个的话，其实要不然就是我们直接建一个新的库，然后你就把那些提交上去，那个 Go module 什么放上去就行。但是你现在是不是有依赖到一些东西啊？因
依赖
为具
什么东西？
体的代码我还没看，比如说依
没有没有
赖了什么 Beehive 之类的，
没有。
没有是吧？没有的话，那应该还好。
对。
没有的话，应该还好。要不先那个吧，先写个 readme 放着吧。等一下我们到时候看一下那个，就因为将来如果拆库的话，其实还是要有个 readme 说明一下这个，大家找 mapper 应该去哪里找。所以可以先放个 readme 在这儿，然后代码上面我那个大家都 review 一下看一下。Okay, so this one we can get it in. And the edge mesh optimization, this one is still under review. And the KE admin support uninstall Cloud Core as a deployment. Any updates on this? Looks still under review. And optimize output log. All right, so maybe we can just review it and get this in. Maybe edge mesh, we need more discussion. Lint, this is completed. And tests, this is a long-term thing. So next one, fix redownload service file. Any updates on this or just waiting for review?
已经完毕了，那个test 也已经加了。
OK， 那就等最后合入了是吧？Okay. Add the option path, package path, any updates on this? 这个应该有 PR 了，对吧？ 喂，哎，听不清楚。哎，卡了吗？
看哥，他应该是卡了吧？我这里我也知道的，这个 PR 就目前还在实现吧。
OK。Okay, next one. 这个呢？这个 support cloud core running as systemd service. Oh, alright, this one is pending. What about the next one? Use device API both on cloud and edge. And any updates on this?
喂，Kevin 哥，
哎，能听到？
这个是我做的，就是我方这里是有个问题想问一下。
你说。
然后可以先打开那个 PR 吗？就是2140那一个。对。就是我是报名了那个 Community Bridge 那个项目的嘛。然后我跟飞哥说大概说让我做这个，但是我看了一下这边的描述，就是不是很确定该怎么做。然后我大概有两个想法啊，就是第一个是，是说在已有的这个 Edge Proxy 这个 List Watch 上面加入这个支持 Device API 嘛？如果这样做的话，是不是就是我之前问过，上周的时候跟那个罗刚毅老师简单的聊过，他是说让我先去看一个，就是那个另外一个人，就是那个刘志磊是吧？他在开发的那个 Edge Proxy 那个模块。然后我的疑问是不是就是说，如果我要做这个2140这个 issue 的话，是在那个刘志磊他开发的那个基础上加入这个 device API 呢，还是说等他那边实现好了之后，基于这个 Edge Core 这边提供的这个 List Watch 对边缘侧的，比如说一些 map 啊进行重构，还是怎么样？就是这个不是很做的工作不是很明确。
这个其实我还是先说背景吧。背景就是因为我们现在 device 这块的这个云和边的同步，其实不是那个 device CID 的这个 API 嘛。那这样的话，就中间会有很多的这个中间的结构体啊转换的这个逻辑。
现在就是通过那个 config map 来做一个中间的转换嘛，对吧？就是接下去的话，我的理解就是说，如果这部分都实现好了，或者说我们要做的就是说，让它能直接通过 KubeEdge API 的方式来进行一些信息的调用或者怎么样嘛，就不用那个 config map 了吗？还是怎么样？
对，我觉得现在看应该还是按这个方向去，因为 config map 这个带来的问题是，现在那部分我记得好像少一些可靠性的这个能力，而且那个在上面，那个在上面你去构建可靠性的能力，应该还是有一些问题的。对，所以这个可以。
那如果要做的
话，
从哪里开始入手啊？我现在就是不知道从哪里开始入手的感觉。
或者一个方案是这样，你可以先假如说你不等这个 List Watch 呢，你可以先把这个两边这个API 的这份修改先做了也可以，就是结构体改成用 API 的这个结构体。
我不是很理解。
就是因为 List Watch 和我们现在的这个消息通信的机制本身都是这个，只是说白了，只是对象在云和边之间的这个协同嘛。那所以就是说白了，就是一头塞进去，一头拿出来嘛。还有一种就是自己拿出来。所以其实现在主要的问题是说，我们经过 Cloud Core 之后，经过 Device Controller 之后，它其实往边缘发的就不是这个结构体。所以主要是要看这个地方是不是改成 Device API 更合适，然后往边缘发的也是 Device CRD， 然后我们再去考虑去对应的这个，在发给 mapper 之前再去转化成 config map， 是不是这样的考虑？然后这样我们在边缘的这个节点级的持久化存储里面也存这个CRD 的这个 API。
就是还得再具体的话还得再讨论了，就是。
就是这个，其实你还是要写一个，就最后可能其实还是要写一个 proposal 出来，然后再去开始做实现。
我以为的那个 proposal 就是那个龚哲写的那个 Edge Proxy 那一部分，我以为。根据我之前那个罗老师跟我讲的话，我感觉是这么理解的。
那个是 general 的嘛，那个是 general，就是其实你现在要分析的，就是在那个基础上，那么你要分析的是，我们从 config map 直接往边缘发，切到这个 device 的 API 往边缘发有哪些改动点？除了这个 list watch 的机制之外。
行，我得还再去了解一下。
还有个问题就是说，我们到底后面 mapper 的输入是不是 config map， 还是 mapper 的输入就是直接也用 device CRD？ 就这个其实要先把这个搞清楚。
要去重新设计了，对吧？就是 mapper 的输入。
就这个地方你要分析现在的 config map 是不是够，然后我们要不要用这个 device CRD， 还是说继续用 config map？ 继续用 config map， 其实那么你就在边缘有个地方要转嘛，两个格式是要转。
对，
所以这个其实这个是你现在就可以启动分析的，因为 list watch 那个实际上是怎么把这个 API 对象发到边缘去。
OK。
那这个的话，这个应该是进不了 1.5 了。
是不是要改成那个 设计啊 ？Process。
对。
OK。
还有一个，现在那个 device CRD 是没有通过Cloud Core 给发送到边端并且持久化存储的吗？
现在没有，现在发的直接是 config map。
懂了。
我想想 CRD 应该是没有。
我觉得这有
就是 CR 应该是，反正至少 CR 肯定没有，应该是。
那 CR 估计右边那一套应该也是都是需要下发的嘛。
什么？
说就是，其实现在右边是就 Cloud Core 可能是 device controller， 它从API server 获取这个 CR 的之后，然后再把它转成 config map， 然后再下发下去，然后再给那个 event bus 或者说就反正右边那一套跟物联网有关的那个框架去，是吧？
对。
那这一套应该全部把它给改成那个使用 device API。那这个应该跟我的那个list watch 应该没特别有关系的吧？或者说 list watch 那边只是说获取，就是你刚才说的获取这个 API 的方式而已。那现在的方式要么就走那个现在原有的通道也是可以的。
对，就是说如果原有的通道其实是要解决那个可靠性发送的问题，因为原来就是它的有一些从事没有加上去。
对，那里加一点就是原有的通道也是可以的，可以把它用上来，所以 list watch 那边是可用不可用的。
对。
好的。
Okay, config domain URL for Cloud Core. This one is implemented, and the upgrade to Kubernetes 1.19. Yes, this one is already, I think already got some review. just need a final review and approval. Okay. The original E3 test, this one is still under test. Okay, oh yeah, we already have the result.哎，这个上周有讲吗？还是这周要讲一下？大家先看吧，我们这个会议有点超时了，抓紧一点。
这个戴霞上个星期讲过了。
Okay. All right. So we have the list. We just need to check if any issue we need to fix. Okay. Gateway to edge. So this one is under design. Probably not able to get in 1.5. All right, that's all about it. Any other comments or discussions? 好的，大家有没有什么问题要讨论的？行，没有的话，就是已经完成特性的同学检查一下自己那个对应的一些文档，这些是不是都要开始写起来了 ？All right, so for these features and works already done, we still need to double check if we have finished the document work. If not, please update the document, especially the user guide and the user manual. All right, that's all about the meeting things today, I think. All right, thank you all for joining the KubeEdge community meeting. So the next time will be November the 4th, Pacific Friendly Time next week. Thank you all again for joining. See you.